So we're going to look at a few basic problems with conditional probability in this video. And starting with this example, number 1, a standard deck of 52 cards is well shuffled. Okay, we don't always say that in a problem, but it is important in terms of really achieving a randomly selected card. All right, so if it's shuffled really well, then find the probability that the card is a king, given that it is a face card. So remember, the given means that we're reducing our world to this part of the original sample space. Right, so I have the entire sample space for cards, which is any card that you can get, but now we're saying, okay, given that it's a face card, so we know it's a face card, so of the face cards, how many ways are there to get a king out of how many? So the, let me color code that too. So the card is a king, right? So we're going to have the probability of a king given a face card equals, so I'm going to color code this. So the probability of the king, so how many kings are there in the world of face cards? There are 4. And how many, okay, so yeah, how many face cards are there? That is a total of 12. So the probability of a card being drawn, and it is a king, given that you know it's a face card, is 4 out of 12. We could reduce that to 1/3. You don't have to. So this, let me do it in white. So this fraction is fine, right? I'm not looking for you to prove that you know how to reduce fractions. I just want to know that you understand what's going on with conditional probability. So this fraction is acceptable. No need to reduce. But it's like a compulsion for me to reduce it, so I just can't not. All those years of algebra. Okay, so it's about 1/3, right? And that makes sense. I mean, part of why I reduced it is because I like to see, right? This is 1/3, right? So the queens are another third and the jacks are another third. All right. So in this example, number 2, 2 6-sided dice are rolled. Find the probability that the sum is 8, given that the first die shows a 3. All right, so we have seen a whole table of all 36 outcomes for a 2 6-sided dice. So remember that there's 6 times 6 equals 36 outcomes for 2 dice, right? For rolling 2 dice, right? But now we don't need the whole table because it's telling us that given that the first die shows a 3, and so we can look at the sample space of all of this is going to be, so we're only going to be interested, the first die shows a 3, so, and there's only 6 options, so I'm going to write them all out. So there's 3, 1, 3, 2, 3, 3, 3, 4, oops, and 3, 5, and 3, 6. right? So if the first die is going to be a 3, then the second die can only be 1, 2, 3, 4, 5, or 6. So this is the world that we've reduced it from 6 possible outcomes. From 36 outcomes to 6, because we're fixing the first die as 3. And so let's see how many of these equal 8. So 3 plus 1 equals 4, so that doesn't work. 3 plus 2 equals 5, so that doesn't work. 3 plus 3 equals 6, so that doesn't work. And 3 plus 4 is 7, that doesn't work. And so this one's going to work. This is the only one that's going to work, because this is 9. All right, so this is the only one that has a sum of 8. So the probability of a sum of 8 given the first die is a 3 is going to be equal to, so we're going to have one option, the one that I circled, out of the 6 options. So that's 1/6 of a chance. Okay, and so our final example is we have a jar of 6 lemon candies, 10 cherry candies, and 2 candies are drawn at random without replacement. So that means we don't put them back. Find the probability that the second candy is cherry given the first candy was lemon. Okay, so what I like to do is I like to draw a picture of what's happening. So here's my jar. Doesn't really look like a jar, but I'm going to do yellow for lemon. So I have 1, 2, 3, 4, 5. I have the 6 lemon candies and then the 10 cherry candies. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cherry candies. Do you have to draw it? No, but I'm just drawing the picture for illustrative purposes. All right, so what that means is that we have 6 plus 10 equals 16 total candies. And so of those 16 candies, on the first candy, so we're going to take the first candy times the second candy. And so, nope. Tripping here. We're not going to do that. We are going to, so I had to remind myself of what the problem was. The problem is the probability that the second candy is cherry given the first is, I'm just going to write lemon. The first is lemon. All right, so we already know the first is lemon, so we're going to go ahead and cross out lemon. That one's been pulled out. So what this means, instead of a total of 16 candies, you now have 15 that I'm drawing out of, and so my cherry is now 10 out of 15, and that is 2/3. Right, so if you take the cherry, or say if you take the first candy out and it's lemon, then you have 15 candies left. So the second one is, there's 10 options for cherry for the second candy that you take. And that's all for our basic examples. And I'll do another example of a more complicated conditional probability, or another video.